Dear learners, welcome to the lecture on the topic acid rain and ozone layer depletion. I am Dr. P. Bhanuprakash, lecturer in chemistry working in PVKN Government College Autonomous, Chittoor. Learning objectives. In this lecture, we are going to discuss about the following subtopics: acid rain and different forms of acid rains, harmful effects of acid rain and prevention methods of acid rains, dual role of ozone, depletion of ozone layer, causes and effects, solution to ozone layer depletion. What is an acid rain? Anthropogenic activities like fossil fuel combustion in thermal power stations, in different industries, and natural volcanic eruptions releases huge amount of sulfur dioxide SO2 and nitrogen oxides NOx into Earth's atmosphere. The SO2 and nitrogen oxides released by the anthropogenic activities are then dispersed into atmosphere by wind currents and react with the oxygen and water in air to form sulfuric acid and nitric acid respectively, which means that SO2 will be converted into sulfuric acid and oxides of nitrogen will be converted into nitric acid in the presence of water and oxygen in air. These acidic components like sulfuric acid and nitric acid finally fall back onto the ground in the form of rain known as acid rain, or sometimes it may reach the earth's surface in different forms like fog, frost, snow. This is known as acid deposition. Let us understand about pH scale. pH is a measure of how acidic or basic the solution or water is. pH scale ranges from 0 to 14, in which a reading of pH equal to 7 indicates the solution is neutral. If pH is less than 7, then the solution is acidic. If pH is more than 7, then that solution or water is said to be basic in nature. The unpolluted rain has pH value not lower than 5.7 due to formation of weak acid carbonic acid by the reaction of atmospheric carbon dioxide with water. Demineralized water, we can say it has a pH value of 7 which is neutral, but unpolluted rainwater has a pH not lower than 5.7 because the atmospheric carbon dioxide will be dissolved in water to form weak carbonic acid. On the other hand, acidic rains have very lower pH values which is around 4 to 5 on the average. This is because of the presence of strong acids like sulfuric acid and nitric acid in that rain when compared to the weak acid in like carbonic acid in unpolluted rain. Let us discuss about different forms of acid rain or acid deposition. Acid deposition takes place in two forms, one wet form, other one dry form. In wet deposition, it is any form of precipitation like rain, snow, fog, frost that removes acidic pollutants from the atmosphere and deposits them on the earth's surface. In dry deposition, the polluting acidic gases like oxides of nitrogen and oxides of sulfur may stick to the ground or plants or building surfaces through the dust and smoke in the absence of rain. What are the harmful effects of acid rain on soils and plants? Acid deposition with pH ranging from 4 to 5 dissolves and washes away the essential nutrients present in the soil, which are very much needed by the plants or trees to grow. This ultimately leads to the decrease in productivity. Acid rain increases the leaching of important minerals like potassium, phosphorus, magnesium and calcium from terrestrial soils. In simple, it impoverishes the soils. Definitely, the impoverishment of soils will affect the agricultural yield. As acid rain falls on trees, it can create holes on the waxy coating of the leaves, causing brown dead spots, which affect photosynthesis or makes them lose their leaves. In some cases, the acid rain damages the barks of trees, which stunt their growth. Definitely, such damaged trees or damaged parts of trees are more vulnerable to diseases and insect destruction. Harmful effects of acid rain on materials like historical monuments, statues. Acid rains accelerate the deterioration of buildings, automobiles, railroad tracks made up of metals, steel bridges and other structures which are made of limestone, that is calcium carbonate, marble, again it is calcium carbonate or any metal. Acid rain causes corrosion to historical monuments or statues by reacting with metals or minerals like limestone, that is calcium carbonate present in the stones. Acid rains damage even concrete buildings and artworks made with cement in highly polluted cities. Corrosion of historical monuments. Here is an interesting example, Taj Mahal. It is a beautiful monument which is made up of white marble stone, that is calcium carbonate. It is turning yellowish due to corrosion by acid rain. The excess emissions of oxides of nitrogen and sulfur in the Earth's atmosphere in the surrounding industries of Agra are responsible for the acid rain. Now, the government of India has established strict control on local emissions to protect the beauty of Taj Mahal. Statue of Liberty. When Statue of Liberty in New York was unveiled in 1886, it was shiny reddish brown in color. At present, the corroded statue looks green. The reason behind this corrosion is the outer surface of the statue has been covered with thin sheets which is made up of copper. This copper is eroded or corroded by oxidative reactions and acid rains. Effects of acid rain on aquatic systems. As acid rain flows as groundwater and reaches water bodies like wetlands, rivers, lakes, this definitely alters the composition of water. That means the water will become acidic. This does not support plant and animal life in aquatic ecosystem and keeps them at risk. Acid rains can dissolve naturally occurring minerals like aluminum, zinc and mercury, which in turn pollute the water. fishes caught in these polluted waters may be harmful to human consumption. Drinking water in the fresh lake is poisoned by acid rains. Therefore, in this way, even it poison the drinking water in lakes. The acidic particles that contribute to acid rains may even penetrate into the lungs and affect the respiratory system in human beings. Let us discuss about the prevention methods of acid rains. The best way to minimize the acid rain is to reduce the emissions of sulfur dioxide and nitrogen oxides in the atmosphere, but this can be achieved by restricting the burning of fossil fuels in thermal power plants and different industries and even in automobiles. Switching to cleaner burning fuels like natural gas rather than coal, or even using lower sulfur content coal is better option to prevent acid rains. Focusing more on renewable energies like solar energy, wind power energy, geothermal energy may definitely reduces the emissions of sulfur dioxide and nitrogen oxides into atmosphere. Use scrubbers in smokestacks in industries to control emissions from burning fossil fuels. Use catalytic converters in automobiles to reduce the effects of exhaust fumes into the atmosphere. Confine the use of artificial fertilizers and pesticides. We know that artificial fertilizers generally contain nitrogen, hence they act as a source for nitrogen oxides, which causes acid rains. Acid rains decreases the pH and increases the soil acidity due to leaching of minerals like calcium ions and magnesium ions. Hence, the powdered limestone, that is calcium carbonate, which is basic in nature, can be added to the soil to neutralize the acidity of soil. This process is known as liming. The liming process increases the nutrient availability and also increases the nitrogen fixation capacity of soils. Hence, it also improves the soil structure. Facts and risks about ultraviolet radiation or UV radiation. Solar emissions, that is sunlight, include ultraviolet radiation and visible light. The wavelength of ultraviolet radiation is 200 to 400 nanometers and the wavelength of visible light is 400 to 700 nanometers, which means ultraviolet radiation has shorter wavelengths when compared to visible light. Ultraviolet radiation is divided into three regions: UVA, UVB, UVC. UVC, the wavelength of UVC is 200 to 280 nanometers. It is the most damaging type of ultraviolet radiation, but it is completely filtered by the atmosphere and hence it does not reach the earth's surface. Therefore, there is no problem with the UVC as it is completely filtered by Earth's atmosphere. The wavelengths ranging in between 280 to 350 nanometer is said to be UVB. UVB radiations cannot penetrate beyond superficial layers of skin and hence they damages only outermost layers of the skin. It is responsible for the delayed tanning and skin burning. Most of these rays are filtered by ozone and hence they do not penetrate through the Earth's atmosphere if ozone is in good concentration in the atmosphere. This UVB radiation do not penetrate through glass. Until ozone is there, we don't face any problems with UVB. The radiation of wavelengths in between 315 to 400 nanometers is said to be UVA. It is less intense than UVB but penetrates deeper into the skin. It is everywhere present, even when it will comes to the Earth's atmosphere. No gas in the atmosphere and no layer in the atmosphere stops UVA. It penetrates deeper layers of the skin. It is associated with the immediate tanning and skin aging and wrinkling. UVA accounts for 95% of the UV radiation reaching from Sun to Earth. These UVA rays can penetrate through atmosphere and even through glass. Dual nature of ozone in global climate change. Ozone layer is a thin layer in the stratosphere region of Earth's atmosphere that absorbs harmful ultraviolet radiation, in particular UVB radiation, and prevents them from reaching the Earth's surface. The abundant oxygen molecules in Earth's atmosphere are dissociated into oxygen radicals when they are energized by sunlight. These oxygen radicals collide freely with other oxygen molecules to form ozone molecules in the lower stratosphere layer, that is 10 to 35 kilometers altitude from the Earth's surface. Ozone formation takes place naturally in the atmosphere, but it is very slow. The concentration of ozone in the Earth's stratosphere is sufficient to absorb the UVB radiation up to 95%. In troposphere, the lowest region of Earth's atmosphere, extending to a height of about 10 km from the Earth's surface, ozone is produced by chemical reactions between nitrogen oxide and volatile organic compounds or hydrocarbon emissions from anthropogenic activities. The ozone in this layer, that is stratosphere, acts as effective greenhouse gas. Thus, ozone plays a dual role in global climatic change. When it is present in stratosphere, it acts as a shield to protect UVB radiation, but the same ozone, if it is present in troposphere, it acts as an effective greenhouse gas which results in the global warming or global climate change. Ozone is a highly poisonous pollutant gas at ground level, that is in troposphere, causing respiratory ailments like bronchitis, chest pain and asthma. It even causes harm to vegetation and ecosystem by inhibiting the ability of plant leaves to breathe. Ozone layer depletion and causes for ozone layer depletion. The process of gradual thinning of ozone layer present in the stratosphere is known as ozone layer depletion. The major causes for ozone layer depletion are chlorofluorocarbons, CFCs, hydrochlorofluorocarbons, HCFCs, carbon tetrachloride, methyl bromide and halogens. Chlorofluorocarbons and hydrochlorofluorocarbons are widely used as refrigerants in air conditioners, refrigerators and aerosol spray propellants. These CFCs destroy the ozone layer present in the stratosphere. Oxides of nitrogen released from the exhaust of supersonic aircrafts are also responsible for the depletion of ozone layer. Depletion of ozone layer is found to be more acute in the polar region, particularly in Antarctica. What is the reason behind the depletion of ozone layer in Antarctica? This could be attributed to the prevailing cold climate conditions and air turbulence in the South Pole. Anyhow, the depletion of ozone layer is not limited only to the Antarctica region. Let us understand the mechanism of ozone layer depletion. Once the chlorofluorocarbons reach the stratosphere, the UV radiation absorbed by the CFC breaks the CFC molecule and releases chlorine radicals or even bromine radicals if it is a source of bromine. The chlorine or bromine radicals acts as a catalyst to break down the ozone molecule O3 into oxygen O2 and chlorine monoxide radical Cl dot. The chlorine monoxide radical in turn interacts with another ozone molecule to give two oxygen molecules and a fresh chlorine radical. Since chlorine radical is produced, it initiates the chain reaction. Therefore, several thousands of ozone molecules will be destroyed. It will be converted to oxygen molecule before other chemical processes consume the chlorine radical or remove the chlorine radical from its atmosphere. Effects of ozone layer depletion. Effects on human health. Reduction of ozone concentration at a global scale will significantly increase UVB penetration to Earth. UVB type radiation has potential to affect genetic material and photosynthetic chemicals also. It will affect the human immune system and also causes quick aging, skin cancers, cataracts and sunburns. What are the effects of ozone layer depletion on plants? Reduced leaf size, stunted growth due to minimal photosynthesis in plants, poor seed quality and increased susceptibility of plants to weeds, diseases are some of the effects of ozone layer depletion on plants. Effects of ozone layer depletion on marine organisms. Increased inflow of harmful UVB radiation will deplete the oxygen concentration of marine water. This in turn affects the marine flora and fauna. UVB radiation can also harm the growth of plankton which is consumed by many sea organisms or animals. If once the plankton is destroyed, then definitely it leads to the destruction of entire marine food chain. Effects of ozone layer depletion on materials. The increase in UVB radiation can result in photodegradation of materials of commercial interest like synthetic polymers, naturally occurring biopolymers. What are the solutions to the problem of ozone layer depletion? Decrease the use of private vehicles, switch to public transport and bicycles when distances are short. The emissions from vehicles eventually form smog which acts as a catalyst in the depletion of ozone layer. Hence, prefer public transport and bicycles to minimize the depletion of ozone layer. Avoid excessive usage of ozone depleting substances like chlorofluorocarbons, hydrochlorofluorocarbons, halogens, in refrigeration process. The Montreal Protocol is a result of the efforts being made at the international level to curb the use of the harmful ozone depleting substances like CFCs and other ozone depleting substances like HCFCs. Replace and recycle the air conditioning system and refrigerators that operate on CFCs and HCFCs as refrigerants. Instead of using refrigerators and air conditioning systems which works by using CFCs, prefer the use of or increase the use of the systems which works by using hydrofluorocarbons, HFCs. HFCs do not contain chlorine and hence they are considered to be less damaging to the environment as well as the ozone layer. Restrict the use of chlorinated solvents in industries. As we know that chlorine is playing a key role in the depletion of ozone layer. Preference should be given to those aerosol propellants that does not contain CFCs and HCFCs. Summary. In this lecture, we learnt the definition of acid rain and the two different forms of acid depositions, the harmful effects of acid rain, the solutions and preventive measures of acid rains. We discussed ozone layer depletion. Ozone layer depletion is the process of gradual thinning of ozone layer present in the stratosphere of the Earth's atmosphere. We discussed about the dual role of ozone in climate change, in which it acts as a thermal shield in stratosphere and acts as a global warming gas or greenhouse gas in troposphere. We also discussed the causes, effects and solutions to the ozone layer depletion problem. Thank you.